You're probably doing Retrieval Augmented Generation wrong, aka RAG. Do you notice that the results that you get when you search using RAG kind of suck? That they're just not meeting your standards? That the results seem incomplete? Well, I'm gonna go over today how to use N8N and also a code-based approach to do RAG in a way that is guaranteed to work. For those who don't know me, I'm Hunter Sneed, the creator of Getting Automated. Getting Automated is intended to provide educational resources to small and medium-sized businesses to go ahead and teach them how to effectively use AI and automation tools in a way that's actually practical and realistic to their business. Beyond that, I also run Workflowzy, an automation consultancy that goes and performs the actual automation implementation for those who don't want to build it out themselves or maybe don't have the time or resources to do so. For those who don't know what RAG is essentially the de facto standard for going ahead and using your own data with AI. So pairing it with some sort of model that's available, like a GPT-4o or a Claude Sonnet 3.7, and searching your own data with that model to go ahead and get contextually relevant results back. And so RAG is really hot and it's been around for a while, but there's still a lot of issues of how people are approaching RAG today. And so that's what we're looking to try and solve here. So let's go ahead and get right into it. So at a high level, I want to go ahead and get right to it and say that N8N for RAG at scale is really not the right tool for the job. N8N is a phenomenal tool. It can do a lot of things really well. It's a great workflow orchestration engine as a whole. That said, N8N was never intended to be this large data, big data tool that goes ahead and actually processes hundreds, if not thousands, if not tens of thousands or hundreds of thousands of documents to add them to a RAG database. The reason being that it's much more visually based than a lot of the kind of data-oriented tools. And again, it's just not optimized for hundreds of thousands, if not millions of transactions in a single execution or single workflow run. It's really more so optimized for kind of your incremental or ongoing tasks. Again, not your like really complex, really long-running jobs. There will be people that will push the limits of what N8N can do, but this is really not what it's built for. N8N also is limited by the amount of memory and concurrency that you can actually do. With a lot of these big data tools and these dedicated kind of platforms for ingesting data, a lot of times they have significant resources associated with it. This can be 32, 64, 128, even more memory than that, maybe 512 gigs of memory on a server to go ahead and actually perform that ingestion. So N8N and the server that you're running it on probably aren't equipped to go ahead and have kind of the memory and CPU requirements that you would need to be able to actually do a bulk ingestion of data at scale. At the end of the day, N8N is really not meant to be a purpose-built RAG tool. While it can do RAG in a smaller kind of implementation or smaller scale, that's not what it was built for. So to start, you're probably using the wrong tool for the job, but I'll tell you how to go ahead and correct that and what N8N is great for in a RAG process that's not ingestion. So here's what to expect. We've built out both a code-based and an N8N-based approach to RAG. If your RAG requirements for what you're looking to build are not that significant in terms of scale and size, N8N will probably be just fine. That said, if you want to go ahead and build out a really complex or robust RAG with a bunch of different document types, table extraction, image extraction, all sorts of kind of fancy bells and whistles and features, then I'm going to definitely recommend the code-based approach that goes ahead and gets in the kind of the nitty-gritty and all the fine-tuning that you can do with RAG today. So when you break RAG down, it really kind of breaks down into just four main categories. There's data loading and parsing, there's metadata, there's chunking and embedding, and then there's vector database integration. So data loading and parsing is exactly what it sounds like. It's basically taking the data that you have, extracting it from the file that it comes from, and then doing something with it, in our case, actually going and embedding it and putting it into the vector database. So the problem with it is that a lot of people and a lot of the RAG approaches that I've seen with N8N are kind of a one-size-fits-all. And they're maybe only looking at a single file format, or they're looking at a single file format, but they're not actually cognizant of the contents of that file format and how that could matter in terms of what you want to extract and actually put into your RAG database. An example of this is something like a Google Sheet or a Microsoft Excel document in its contents is going to be very different than a dump of Slack messages. And so with that, you really want to make sure that how you're extracting data, not only the actual content of the data, but also the metadata, is aligned with how you actually go about building out the kind of data loading functionality that you're looking to achieve. Beyond that, I see people not really do much with metadata. They don't know what to do with it. They go ahead and they include the bare minimum, if nothing at all. Metadata is so powerful in a RAG. And the reason being is that with metadata, what you can do is you can effectively filter what's being searched on before you even perform the search. And so you can filter out maybe 80-90% of the documents that would typically be searched on before you even perform your actual AI search and get the results back. And so you're really effectively limiting the subset of documents you're searching against to get only the most relevant results. And that makes a huge difference, especially when you start to run RAG at scale. You've got different business units, you've got different document types, you've got contracts spanning across legal, across accounting, across sales. All of those different kind of documents can go ahead and yield less than stellar results when you're not actually doing the filtering up front to make sure that you're only searching what's actually relevant to your query. Chunking is basically the act of taking a document's data, putting it into pieces, and then creating a mathematical representation of that chunk of data. And so what that allows us to do is when you go ahead and do a RAG search later, basically what you're doing is you're taking the input, so your query, and converting that to a mathematical representation, and then going and searching with that mathematical representation against all the embeddings that have been stored in your vector database to see which ones are the most relevant. By comparing those two mathematical representations, you're able to get the most relevant results back. Now, that said, chunking and doing it right is something that is easier said than done. There are concepts in chunking like making sure that you're having chunk overlaps. So basically that there's portions of the prior chunk that overlap into the next one. So that way, if you're searching for information, it doesn't just return a single chunk that may be relevant to your query, but multiple chunks that are relevant that give a more robust full answer rather than, again, what that single chunk may contain. And so chunk sizing, chunk overlap, all of that's really important. We'll get into some more advanced chunking strategies later, but that's kind of one of the core concepts. And then last but not least is your vector database integration. There's a lot of great vector databases out there, and frankly, most of them don't make much of a difference in terms of what you're using. Whether you want to use something like Pinecone or pvector on Supabase or AWS or whatever it may be, they all effectively work in the same way. It really comes down to the actual integrations that something like N8N provides out of the box that will be the differentiator for what vector database you choose. In my case, I chose Supabase because it's pretty well adopted by N8N and is something that we can go ahead and work with pretty easily within N8N. So I already kind of alluded to what's important. Now let me tell you where things typically go wrong. Typically, I'm seeing improper data loading. And so what that means is they're doing a one size fits all. They may only have coverage for a specific document type. Maybe they're only looking for Google Docs document types. But a lot of times you may have information within a PDF, or the information within a PDF may be within a table within a PDF, or an image within a PDF. All of these things matter in terms of how to actually extract information in a meaningful way and then be able to search for it in a meaningful way as well. The bad chunking and embedding is when you don't do things like having overlap, when the chunking that you're doing doesn't have metadata associated with it, when the embeddings, when you're actually doing updates, aren't updating the actual embeddings. There's all sorts of ways where embeddings can go wrong that you need to be aware of. Bare bones metadata strategy, we already covered this a little bit, but please, please, please put some effort into the metadata that you're capturing when you're actually going to create the embedding and chunking and putting that into your vector database. It'll save you a ton of work later. Stuff like making sure that you can go ahead and denote permissions if possible, as well as business unit and versioning and whatnot are all really important parts of a metadata strategy. And then last but not least is scalability and tooling. Using the right tool for the job is really important. And so we already touched on how N8N at scale for something like RAG is really not your best option. And so you want to be cognizant of that, and depending on the volume that you have, either pick some sort of built for you RAG solution, which there are a bunch of them out there, or go ahead and build out a customized, optimized version using something like LangChain for Python or LangChain for JavaScript to go ahead and do that for you. Now for the tools. So under the hood, N8N is actually using LangChain. And LangChain is basically an AI orchestration library that goes ahead and provides you with out-of-the-box functionality to go ahead and work with different AI functionality and tools, such as vector databases, embedding, chunking, retrievers, all the good stuff that you really need to go ahead and do a RAG architecture. And so these specialized tools provide more than what N8N provides you. A lot of times what they'll do is they'll provide pre-built modules in specifically both LangChain and Llama Index. They provide you what's called document loaders that you can use via code. And these document loaders are basically purpose-built data loaders for specific services. So there may be a purpose-built data loader for Slack. So it expects a Slack file as an input, really probably a JSON file that contains Slack information, and it knows exactly the syntax of that Slack file and how to best take that data out and actually use that within your RAG database. Same with Google Drive, Notion, Airtable. There's all these different data loaders that exist that are open source that you can use that really accelerate the overall time that it takes to ingest data. We're using something like LangChain and get that into your vector database, not only on a kind of initial ingestion, but also on an ongoing basis. They are a huge time saver, and someone's already put the work in to go ahead and figure out what data is relevant for this. So I highly recommend that you go ahead and leverage these if you're doing the code-driven approach. So on the right, I've included what I think great metadata looks like. And when I said, please include as much information as possible, I was not kidding. It's really kind of the secret sauce of what you're trying to do when you're going and actually querying data and getting the most relevant responses back. So you can see in this, I've got all sorts of Google Drive metadata in terms of the title, the folder that it's in, who has permissions for it, the source type, the content type, all of these things matter. Because again, I can go ahead and I can narrow it down and say, all right, I want to go ahead and search for documents that only I own. And then when I do that, I'm only searching across, again, a much smaller subset of data than what would otherwise be the entire company data or entire RAG database's data. And so with that, you can go ahead and key on things to make it really, really fine-tuned and make sure that you're getting the most relevant responses back. So great metadata makes all the difference in the world, and it's something that the tool that I've built out via Python can go ahead and do this for you as well. And we're doing some of this in N8N too. Okay, so let me go over the high-level architecture, and then I'll go ahead and I'll run through in both N8N as well as Python how to actually go ahead and do this and what your results will look like. So at a high level, we're going ahead and we're taking data from Google Drive. It seems to be one of the de facto sources of where people are storing their data and what they're looking to actually extract from. Then from there, we're using a data loader in the case of the code-based approach. In the case of N8N, we're doing some switch calls and basically going ahead and parsing out the documents. I'll go ahead and show you what that looks like. Then from there, we're loading it into our vector database. This is where the chunking and embedding and everything else occurs. Then we have the actual retrieval portion. This is where you're actually using N8N to get data out. And then last but not least, the AI app and workflow. And so just to give you a preview, this is what it looks like. And we'll go ahead and we'll flip right over now to N8N. All right, so in this workflow, I've got a bunch of things I want to call out. One of them being on the left-hand side, I've got all these instructions for how to actually go and configure Supabase. I know this is a pain point for many folks, so I wanted to make it really easy to go ahead and just basically copy this in and get everything all set up in one shot. Now, if we look at the actual workflow and what we have going on here, you'll see a couple things. You'll see at the very beginning, I've got a Google Drive trigger for when a file is created or when a file is updated. The idea would be that when you go ahead and add files to a specific folder within Google Drive, in my case, I created one called N8N RAG content, that you could go ahead and basically add files there and have this run on demand. So I haven't activated this, but you could have this where anytime files are added, it goes ahead and it runs this and it automatically adds that data to your actual RAG database. And so with something like this, what we're doing is we're actually getting the file metadata. And this is something that's really important. There are some ways that you can do this within N8N natively, but I found that this was the most consistent way to get all the fields out. And so what this does is this actually gives us all this great metadata that Google Drive provides out of the box that we can go ahead and then use in our actual embedding of the file. And so you can see there's a lot here. I decided not to use every single one of them, but I've used a lot of them. And so I get this metadata, and then what I go and I do is I actually download the file. And you need to download the file because in order to extract data from it, you actually have to have the file to, again, pull the data out of. Now, this is where it gets a little wild. I've got all these different switch rules that basically check the file extension of what it is that I'm looking to go ahead and parse, and it'll go ahead and route it accordingly. And what you'll notice here is some of these have built-in functionality within N8N. So for instance, PDFs, CSVs, Excels, text, JSON, all of that's built into N8N, and that's great. But some of the most common file types that people are looking to get data out of, such as docx, which is a Word doc, or doc, as well as some Markdown and some other file formats, which we can go ahead and expand beyond what we just have here. Those don't have native capabilities to do that. And so this felt like a major shortcoming. And what I actually did was there's a tool that's called Pandoc. And Pandoc is this big data converter where basically you go ahead and you provide a document in, and then you specify the format that you want it to go ahead and put it out in, and it will actually perform that conversion for you. And so with this, I put this in an AWS Lambda function. If you're not familiar, please check out my prior video where I go ahead and go over kind of why I love these and why I use them all over the place. But basically what happens is I go ahead and I extract the data out. So I'll go ahead and I will do that here. We'll give it a second to execute, and it extracts the data out in what's called base 64. And so then what I do is I pass it over to my convert to text. And so it's just the pandoc lambda function. I'll be providing the code for the workflow, the Python-based ingestion, as well as the actual pandoc lambda function as well, all in the description, so you can go ahead and find it there. But basically all you need to do here is you have to specify what's the input format, and then what's the output format, and then what's the content. And so I'm just taking this data that's in base 64 format and I'm passing it in. And so when I do this, typically it takes a second to run. I'll go ahead and I'll exit out. But what it'll do is it'll go ahead and convert that actual data. And so you can see here, I've got the actual data in here that has the kind of the information from the statement of work that I'm using as the test file here. And it goes ahead and it extracts all of that in a nice JSON format. Then from there, I go ahead and I remap it, so that way it's consistent with how all the other stuff is being mapped. And what you'll notice here is I've got some information about my Supabase database, as well as the URL identifier, or the table name that I set up with that script that I had referred to earlier, as well as the file ID. And so theoretically within this, you should be able to use a specific node within Supabase that I was having issues with for whatever reason with this get many rows, where you go ahead and you specify the table and then you build the filter and you make it a string and paste that in there. It wasn't working for me for whatever reason. So I went ahead and just used the HTTP request node that reaches out to my Supabase table and goes ahead and does that for me. And so basically what this does is this goes and checks, does this actually exist within the table already? And if it does, it'll go ahead and route that data accordingly and delete the row and update it if it already exists. And if it doesn't already exist, what it'll do is just add it to the database for the first time. And so we'll go ahead and we'll run this step. We get all of our information out. We then check to see if it exists. If it doesn't exist, it'll return this blank output like this. This is expected. Then it'll go ahead and we'll run this. And because it's false, it goes ahead and it will move on to the next step. And this is where we set the data. So we go ahead and we set the content here of what the actual input is that we want to be. And again, that just all comes from this step right here where we're doing the extraction. So we'll go ahead and we'll run that. And then we'll go ahead and we'll actually add it to the vector database. And so we'll go ahead and click on test step. And this is going to go ahead and now start adding those items to the vector database. And so if I go ahead and I flip over, you'll see it's empty. If I refresh in a second, there we go. It's all in here. And it's got the content information in here, but then it's also got really great metadata. Let me go ahead and expand this. You can see all the metadata that I can go ahead and use to actually perform a more filtered search. And so again, this is super valuable and something that I can't emphasize enough how much it'll make a difference. So we'll flip back to this and you'll see that it added 37 items. Now, if we go ahead and we run it again, what we should see is that it'll go ahead and it'll actually find it and it'll delete those rows out. And then what it'll do is it'll go and actually recreate them and with the latest and greatest version. And so this is a way to make sure that the latest version of your file is always the one that's within Supabase. So that way you're always querying the latest file versus some old file that may have multiple entries and may give you inconsistent results back, which is obviously definitely not what you want. And so we've got all of that there. One thing I do want to call out here is the advanced chunking. I do want to highlight that the chunking that you can do in here is pretty limited. So you can go ahead and outline what the actual data loader information is. And you can also outline the chunk size and chunk overlap, but it still leaves something to be desired. I'll show you kind of the differences in my code-based approach, but then again, it's better than nothing, but I still think this is an area that N8N could really grow in terms of its functionality that it provides. All right, now I've went ahead and jumped into my enterprise-grade RAG with Supabase. And so this is where I really kind of want to show some of the more advanced ways to do things that you should be thinking about when trying to optimize your RAG results as well as RAG ingestion as a whole. And so what this is doing is it's doing a number of things. It's tracking document versions. It's doing a rich metadata extraction like we just saw. It's actually doing OCR on some of the text that exists in documents and some of the tables and figures to extract that out. It's doing image extraction as well. It's got all sorts of parallel processing, and it's doing respectful content chunking, where basically it's going ahead and looking at where content begins or ends and is respecting those boundaries. So you don't have chunks that have data that's not related to each other being actually collected. And so I'll go ahead and I'll run this and show you what it looks like. In this, I've actually built out all of the different functionality that you need. So authenticating into Supabase, the ingestion into Supabase, how to query, how to store, and different utilities. And then I've built out this example as well. So let me go ahead and I'll actually run this. And you can kind of see what's happening in this as it's all happening. So it takes a second to start. So we'll let it go ahead and start up. but this will go ahead and it'll pull all of the different data within that specific Google Drive folder that I pointed it at. And then from there, it'll actually go and do advanced chunking and ingestion functionality to make sure that it's actually only ingesting the net new data. So it is checking what was old and what was in there before versus what's new. And it's only ingesting what it needs to, but it's doing an advanced ingestion strategy for that. And so with this, I've got a couple different features and functionality here. There's basic ingestion, advanced, specific, and then enhanced media. With this, I'm gonna go ahead and just do advanced for now. You've got options for what you wanna do. There's no advanced tables or anything else like that in my version. And so I'm not all that worried about it. But what you'll see here is it goes ahead and it shows the advanced RAG pipeline, and it shows that it's using LangChain to actually do this. And then when it goes and it does this, it actually goes and pulls from Google Drive. And so it goes and authenticates from it. And then from there, you can see the content aware chunking that goes ahead and figures out kind of what the right overlap is and everything else. And then from here, it actually goes and it will set the chunk size as well as the overlap. There's some kind of variation in how big the chunk size can be and how big the overlap should be. 500 and 100 can be a good combo, so can 1000 and 200. It really depends. This is something that's going to depend on your data and something that you're going to want to play with. So don't take this as kind of the best or the right, kind of chunk size and chunk overlap for your data, but it'll go through and you can see that it's making the different chunks. So each actual chunk has its own metadata and its own information associated with it, with the data that's within it. And if we keep scrolling down, it's going to go ahead and keep processing, and it says that there's 82 unchanged documents because I've already went and embedded these documents in my vector database. So that way it doesn't have to reprocess these and pay for the embeddings again. Every time you make a call to whether it be OpenAI's embedding API or anything else, it goes ahead and it actually charges you for that. It's pretty nominal in cost, but still, let's not spend money when we don't need to spend money. And so it goes through this whole thing. And then what you'll see here is it says again that at folder 2, there's a bunch of unchanged documents. And it goes ahead and it provides back some information about the document version, the permissions around the document. It goes ahead and gives a preview of what it is. So this is an extract from the actual document, as well as a chunk level metadata. So not only does your document have metadata, but also each chunk, which is the pieces of the document, have metadata as well, that if you really want to get granular with it, you should be cognizant of, and again, go ahead and tag that accordingly with your metadata. And so we get some more metrics about it, talking about how we're using super-based PG vector, and this is the table that it went to, and this is all stuff that's configurable in a .env file that I've went ahead and created that I'll be sharing with the repo, as well as a really detailed README. But basically, it'll go ahead and talk about the new documents, the updated documents, and unchanged documents, and then gives you a breakdown when it's actually done and some other properties about the document. And so as you can see, this is a pretty robust way of approaching it, and the README also breaks it down too. So let me go ahead and I'll pull this down and it'll kind of walk through what this all looks like. These all actually render out on GitHub. So basically it talks to you about how to set this up, and it also goes over, and let me actually flip to GitHub and I can show you what those look like. It shows you end to end, what's actually happening. It shows you all of the flow from the Google Drive to the authentication to processing the documents, kind of how to actually go about setting up the Google Cloud access. I'm using a Google Cloud service account for this, which typically is going to be better than something like your own kind of OAuth credentials for your own user. This is something that you can have be more of a persistent account that lives on versus having your OAuth account where their password might change or something might change and you might get timed out. Service credentials for this or service accounts make a big difference, specifically with Google Drive. And so yeah, it's pretty robust. Definitely take a look at this. This should have all the information that you need to get started with it. By no means will this be a one size fits all. Again, your data, your mileage may vary, but I want to go ahead and make it available to everyone to be able to use and try and modify as they see fit. And so it's got it all in here, and that's great. I just showed you two different ways to go ahead and ingest data for a RAG application. And so when you ask me what would you do or how would I go about it, my answer would be I probably would do the RAG ingestion with some sort of code-based approach because I can get a lot more flexibility and a lot more kind of benefits out of that. And then what I would do is I would use N8N for the actual retrieval. And so then I can actually go ahead and get the data out in some sort of agent-based workflow, typically kind of what you're using RAG for, where you're doing those searches, and using N8N to do that. N8N doesn't really have an issue with searching. It's more so the actual embedding process. And again, you can get just so much more granular with something like a code-based approach and your kind of own customizability there versus N8N with the actual ingestion. So a little bit of a hybrid model, code for ingestion and then N8N for actual retrieval. It works really well, and it's something that I've set up for a number of clients. Now, I'm super excited about the community that I've launched within the last month or two. It's going really well. We have a number of live events each week, and it is the premier spot to go to for real automators that want to roll their sleeves up and see automations that don't just look great on YouTube, but are actually practical and scale with you and your business. These are real automations that you can rely on, not something that may fall over as soon as you throw something different at it. If you haven't joined my community already, you should definitely take a look. It's intended for real builders that want to go ahead and build real business-focused solutions that scale, that are reliable, that can actually be used in a business beyond just a YouTube demo. I'm seeing a lot of subpar, half-baked solutions out there, and really what this community is looking to try and address is how to actually build solutions that are production ready, that will go ahead and be resilient, that have the business SLAs and SLOs in mind, and are something that, again, are actually tangible and stood up in real businesses. I've gotten all this experience from running my automation consultancy, and now I'm here to share it with you to go ahead and show how you can actually implement this in your business in a meaningful way. You can go ahead and learn more about it and sign up today at resources.gettingautomated.com. I hope to see you there. That should wrap it up for today, and I just wanted to say thank you so much for watching. It means the world to me. Like, subscribe, comment. It really helps me continue to make videos and continue to try and share my love for both AI and automation with those that want to go ahead and learn more about it. If you have any questions, feel free to reach out. You can go ahead and reach me at hunter@gettingautomated.com, as well as on my website and in the comments. So please go ahead and leave comments as you see fit, and I can't wait to hear from you all and continue to automate within this space. So with that being said, have a great day and good luck automating.